In the space of science and huge secrets, the subject of what existed already before the immense blast has mixed discussions and charmed characters for a surprisingly long time. This gigantic demand doesn't simply test how we could translate the universe. It challenges the veritable farthest constraints of human information. Envision remaining at the edge of presence, investigating the enormous shadowing and contemplating what lay there before our universe was envisioned. The event of the enormous detonation marked the dawn of mankind, space, and all that we know. At any rate, was there a moment before this, perhaps a state of nothingness, a quiet before the grandiose event began? And if this is valid, was it? Or maybe there was something even more disturbing that existed before time itself. As we hop further into this inquiry, science takes us on an excursion past the universe's starting point into considerations that challenge our consciousness. Physicist Brian Cox, known for his examination of the marvel of the universe, suggests that something astonishing could have existed before the huge explosion. He moves us to rethink our thinking of the real world and presence. In this assessment, we'll analyze the science, the hypothesis, and the astonishing insider secrets that may help us understand what existed before everything. We'll investigate ideas like pretentious advancement, quantum changes, dark energy, and even multiverses. The responses we've uncovered may very well incapacitate you, but they could also open new understandings of our situation in the universe. Prepare to hop deep into a world beyond imagination and science, where the dark still winds around the shadows, leaving researchers amazed and, at times, even disturbed. We should investigate what existed before the huge explosion and why these hypotheses challenge all that we assumed we knew. To appreciate what might have existed previously, we first need to meticulously dissect what the huge explosion truly was. The enormous detonation, as researchers characterize it, refers to the moment when the universe became very hot and thick, expanding rapidly to set off the development of all matter, energy, and unfathomable forces. When we look toward the night sky, we see evidence of this hot starting universe fanning out this way and that from a single point. However, why did this occur? Was there a period before this thick, hot beginning? As shown by the theory of immense expansion, there was definitely something already, and it was far from void or quiet. Immense expansion proposes that before the large bang, the universe was in a state that was cold, empty, and free, essentially like a colossal vacuum. However, this vacuum wasn't totally empty. It contained a vast amount of energy that fueled the rapid expansion of space itself. This expansion, called inflation, occurred so quickly that it essentially laid the foundation for everything that would follow, expanding at incomprehensible rates until the acceleration slowed, and the energy transformed into matter particles and the forces we see as the enormous detonation. But what was the nature of this energy? Why did it suddenly become the universe, and why did it stop? Subject matter experts believe that this endless development created patches of the universe, each experiencing its own huge explosion. Imagine a fabric extending forever, with infinitesimal air bubbles forming here and there, each bubble representing a universe, including our own. This idea, called the inflationary multiverse, proposes that there are potentially an infinite number of large bangs and a limitless number of universes. Our own is just one of many. This vast, mind-bending reality challenges how we might interpret the very universe itself and leaves us with the question: what else is out there? The idea of nothingness before the enormous detonation is theoretical, not real. However, according to our current understanding, even if you eliminated all energy, particles, and radiation from the universe, it would still not be truly void. Our universe is filled with dark matter, dark energy, quantum fields, and various forces that weave an inescapable web of something, even in its most empty form. Even if we imaginatively stripped away all of these forces, leaving only dead space, the universe would still generate new forms of energy. This reality alone is astonishing to experts, as it suggests that true nothingness may be impossible within our limited consciousness. Space itself has properties, rules, and constants that prevent it from being completely empty. Imagine creating a region with literally nothing in it. No particles, no radiation, and no energy except quantum fields and significant constants. These would still exist, suggesting that this nothingness has properties. For example, there's a characteristic called zero-point energy, which refers to the lowest possible energy state of quantum fields. In this state, particles can still spontaneously appear and disappear, creating a creepy echo of movement, even in what should be empty space. This challenges our understanding of a true void and suggests that, yes, even before the enormous detonation, there was something. Scientists are only beginning to comprehend one of the most fascinating theories in modern cosmology, the possibility of eternal development. If inflation could make our universe exist, it's conceivable that it could continue forever. Brian Cox describes an immensely vast inflationary multiverse where universes are constantly created and continue growing. Imagine each huge explosion as a spark lighting another universe, while inflation continues in different regions, creating countless new universes. This cycle could, in theory, happen forever. This idea of immense universes giving birth to a captivating concept of a fractal universe, where each new universe might actually create its own huge detonation, suggests that each universe exists as a separate, independent space, unaffected by the others due to the rapid expansion of space. For scientists, this theory is both exciting and disturbing, as it suggests an endless multiverse with no definitive beginning or end. Imagine our universe being just a tiny part of a colossal, infinite structure, forever expanding and constantly creating new universes. And what if the unsettling truth is that there is no before or after, but rather an eternal cycle of universes forming and decaying? How we might interpret nothingness changes when we consider quantum field theory. According to this theory, the universe isn't just a collection of matter floating in space. It's a complex network of energy fields that fill the universe, interacting to create everything we observe. These fields are like invisible oceans, with particles acting as waves or disturbances. Even when fields are at their lowest energy level, known as the vacuum state, they are still active. Particles can appear and vanish in these fields instantaneously, gaining energy before returning it. This phenomenon results in virtual particles, entities that briefly exist and then disappear, leaving only a faint memory of their presence. The concept of virtual particles challenges the idea of a true void. Imagine an empty universe where all matter, radiation, and energy have been removed. Would you have absolute nothingness? According to quantum field theory, you wouldn't. Even in a vacuum, fields would remain dynamic, occasionally creating transient particles. This constant fluctuation in what should be nothing suggests that the universe doesn't. Vacancy. The fields and powers persevere through filling the universe with a secret energy that forestalls outright nothingness. This grasping raises a charming question. Assuming that fields make particles and particles make matter, could the universe itself have risen up out of this nothing, loaded up with quantum fields? Dark energy is a strange power that, as of now, drives the accelerated extension of our universe. Yet, did dark energy exist before the Big Bang? From certain viewpoints, the way that dark energy exists today is an echo of an energy field from before our universe's development. The properties of dark energy seem to propose a giant, hidden force that could have existed in some form before the Big Bang. A few speculations suggest that dark energy, in a much stronger state, might have controlled the inflationary stage, causing quick development. The presence of dark energy suggests that whether or not our universe were depleted of all matter and radiation, this power would proceed to grow the fabric of space-time. This thought prompts a disturbing inquiry. On the off chance that dark energy was present before the Big Bang, might it at some point have formed the conditions that led to the creation of our universe? Might dark energy at any point be the quiet planner of inflation, or even the true origin of our universe? As we explore this possibility, we face the potential of dark energy not merely as a force shaping our universe, but as a key that could unlock the mysteries of the multiverse itself. Another hypothesis that offers an alternative to the Big Bang as a definitive beginning is cyclic cosmology. In this model, the universe goes through vast patterns of birth, death, and revival. The Big Bang is not a one-time event, but perhaps part of an immortal cycle where universes expand, collapse, and then regenerate in another cycle. This theory suggests that our universe could have been reawakened from the remnants of a past universe. The process of contraction and expansion in a cyclic pattern would mean that there was never a true beginning, but instead a timeless series of universes arising, developing, and regenerating themselves again and again. Cyclic cosmology raises huge questions of its own, as it suggests that time itself may be repeating rather than linear. If this theory is correct, it could imply that what existed before the Big Bang was simply another version of the universe, one that imploded solely to give birth to our current universe. For specialists, this theory offers a rich answer to the question of extreme beginnings, suggesting that there is no clear starting point. The universe has always existed in some form, transcending our notions of time and existence. Gravitational waves are another intriguing idea that could hold hints about what existed before the Big Bang. Gravitational waves are ripples in space-time caused by enormous cosmic events, and scientists believe that early-stage waves, if ever detected, could provide insights into the universe's earliest moments. These waves could serve as the echoes of what preceded the Big Bang. If detected, they could provide evidence of the universe's past states. The potential discovery of early-stage gravitational waves is one of the most exciting prospects in cosmology today, as it would not only uncover the truth about the Big Bang, but also offer a glimpse into the cosmic state before our universe was born. This theory presents an enticing possibility, identifying gravitational waves that could act as fingerprints of a pre-Big Bang universe. As we continue to investigate what might have existed before the Big Bang, we delve into ideas that push the limits of our understanding, challenging even our most basic assumptions about space, time, and existence itself. Perhaps one of the most marvelous ideas comes from the realm of quantum gravity, a field that attempts to combine quantum mechanics with general relativity. This combination might eventually reveal a unified theory of everything and offer insights into what existed before the Big Bang. Quantum gravity proposes that realities are not smooth, continuous substances as we experience them, but rather are discrete, granular structures. This theory suggests that the fabric of space-time itself might have been formed from a minuscule, board-scale structure, with tiny quantum fluctuations shaping the universe in ways we can't yet fully understand. In this view, what we see as the smooth continuum of existence may have simply emerged from these fluctuating quantum fields. Therefore, the state before the Big Bang could be described by a fundamentally different concept of reality, one where space and time themselves were not fully formed. Another possibility is that the universe is part of a vast, cosmic scene of potential universes, each with different physical laws and constants. This theory, known as the string landscape, emerges from string theory, which suggests that all fundamental particles are, in fact, tiny vibrating strings. In this framework, there are many possible configurations of these strings, each corresponding to a different set of physical laws. The string landscape could imply that our universe is only one of many, each emerging from its own distinct Big Bang-like event. The presence of such a landscape also gives rise to the idea that different universes could have different dimensions, varying strengths of gravity, or even different types of matter. In this view, our universe may not be unique, but instead part of a multiverse, an assortment of universes, each evolving independently. The multiverse hypothesis provides a theoretical, though fascinating, answer to the question of what preceded the Big Bang. Another universe, in a different configuration, possibly leading to infinite cycles of creation and annihilation, with no definitive beginning. Furthermore, cosmological models some theoretical physicists play with consider the role of black holes in shaping the nature of the universe. A theory gaining attention is that our universe could be the result of a black hole formed in another universe. In this scenario, the singularity at the center of a black hole could act as a gateway to another universe, with the Big Bang being the moment when such a black hole gave birth to our universe. This theory is supported by the fact that, according to general relativity, the singularity at the center of a black hole is a point where space-time curves infinitely, creating a region where the known laws of physics break down. It's possible that the extreme conditions inside black holes could lead to the formation of new universes, which might suggest that what we consider the Big Bang was simply the birth of our universe from the singularity of an ancient black hole. Exploring these ideas requires a deep dive into the very nature of time itself. Some cosmologists theorize that time, as we understand it, may have had no meaning before the Big Bang. If time began with the Big Bang, then there might have been no before in any conventional sense. According to this view, time itself may have arisen from a quantum fluctuation, or from an early stage where the usual distinctions between past, present, and future didn't apply. This could lead us to reconsider the concept of causality, which relies on the understanding that events occur in a linear succession. If there was no such thing as time in the way we experience it, then the question of what preceded the Big Bang becomes meaningless, as there would be no temporal structure to support it. Further complicating the picture are theories of cyclic time. As mentioned earlier, cyclic cosmology suggests that the universe undergoes vast cycles of birth, expansion, and possible collapse. In this model, the Big Bang could represent merely the latest bounce in an eternal series of universe cycles. These cycles may not be identical, but could develop in various ways, each with unique physical properties. According to this hypothesis, the pattern of the universe would be a continuous process with no true beginning or end, making the question of what came before the Big Bang irrelevant in the traditional sense. The idea that time itself may be cyclical suggests that each Big Bang could be followed by a contraction and another big crunch, with the universe reinitiating itself in an endless loop. Another avenue of investigation into the nature of the universe is the potential for an early-stage soup of particles and fields that existed before the formation of stars and galaxies. This concept suggests that before the universe began its rapid expansion, it was filled with a dense and hot mixture of fundamental particles, including quarks, leptons, and bosons, all in a state of extreme energy. These particles would have been interacting at extraordinarily high temperatures and densities, laying the groundwork for the formation of matter and energy. As the universe cooled, some versions of this theory propose that this early-stage soup existed in a quantum froth, where particles continuously arose and disappeared due to the uncertainty principle of quantum mechanics. The properties of this soup might offer insights into the universe's earliest moments, and also what preceded the Big Bang itself. Eventually, what existed before the Big Bang remains one of the most significant mysteries in science. As our understanding of quantum mechanics, cosmology, and fundamental physics grows, new theories will continue to emerge, offering increasingly complex and sometimes baffling explanations for the origins of our universe. While we may never fully grasp what preceded the Big Bang, the search for this knowledge will continue to push the boundaries of human curiosity, driving us to explore the unknown frontiers of existence.